Okay, so we are going to be continuing to talk about the binomial distribution. So it says here, what is the probability of getting ahead 3 times if you toss the coin 5 times? So if you remember yesterday, we talked about our formula here. So I'm going to write the probability of 3 heads is equal to, well, n is the number of times that you toss the coin, which is 5. K is the number of times that you are successful. Did you sign in at the front? It's 8:33 and you need an admittance slip. The number of successes that you want, so we want to know how many times you get it if it's ahead, and that's 3 times. That's the number of successes you want. The probability of this event happening is 1/2. We know that when you flip a coin. Q is the probability that it won't happen, which is 1/2. When you add P and Q together, it should give you 1 whole or 100%. So when I plugged this in, based on yesterday's formula, Ben, can you tell me what I would write? Mm-hmm. 5 choose 3. 1/2. 3. Mm. So we had our general formula yesterday, which is n over k times the probability of p to the exponent k times the probability of q to the exponent n minus k. Again, that is a formula you have to memorize. I'm not giving that to you. You have to know every formula that I went over yesterday. Hopefully, with all the homework you would have done yesterday, that would be pretty straightforward. Johnny, what do you get when you plug that into your calculator? Could you please do me a favor and follow along as we are doing these questions and have this already in your calculator so when I do happen to ask you, you are able to give me an answer. I would appreciate that very much. Can someone please help me out? What do you get when you put this in your calculator? Thank you. There is a 31.25% chance of getting 3 heads if you toss a coin 5 times. 2 die are rolled 20 times. What is the probability that double sixes are rolled? Exactly twice. So I have my information here. I'm rolling 20 times. So n is equal to 20. I want to know this exactly twice, which is saying k is equal to 2. David, what is my probability that I will roll double sixes? Now 1 over 6, I'm rolling 2 die. You know what, can you help me out? Can someone please help me out? 1 over 36. There's only one way to roll double sixes. That's your first die has to be a 6. Your second die has to be a 6. There's only one way to do that. There are 36 possible outcomes when you are doing your die, that diagram, which means, Powell, can you help me out here? Q.
Attention all staff and students. Attention all staff and students. We are now in a hold and secure situation. Please secure your rooms. Mr. Ford and Mr. Percy, please report to the main
office. So Powell, if I have here my probability of success is 1 out of 36, what is Q? Yes, 35 over 36. How do you get that? You do 1 subtract 1 over 36. Okay, so when I'm setting this up, Mitchell, can you help me out? What am I going to do here? Okay, so the probability of rolling 2 6s is equal to 20 choose 2. Good. Good. To the exponent what? Mm-hmm. Mm-hmm. Very good. And when you put this in your calculator, Spencer, what do you get? I got 883. Yep. Okay, so there's an 8% chance that you will roll doubles, 6s, twice. At least twice. Scott, what does at least twice mean? Right. If I do at least twice, the direct method would be finding the probability of it 2 times, which we found, plus 3 times, plus 4, 5, 6, 7, 8, 9, 10, 11, all the way up to 20. That is not an efficient method. So this is when we would use the indirect method. So the probability of at least twice. Okay, you guys got to turn off the phones. That's driving me nuts. I can hear it on vibrate, please. Is equal to 1 minus the probability of 0 times minus the probability of 1 time. At least means it's including the second one. So Curtis, you were in here yesterday. David, can you please help me out? What do I write? So I'm going to have 1 minus the probability of 0 times coming up. What would I write for that? I start with my choose first. 20 choose 0, because I'm flipping it 20 times and I'm having 0 successes. Okay, continue. No, I have to do the whole formula. So it looks like this. That's one piece of it. Times 1 over 36 to the exponent what? Not to the exponent 2. I'm doing this 0 times. So 0 successes, so it becomes to the exponent 0. What comes next? To the exponent what? Yes. Subtract. Billy, can you do the next piece for me?
Please excuse the interruption. This ends our hold and secure. You can go about business as usual.
Okay, when you put that inside your calculator, the whole thing, I will tell, does anyone have any questions right now about what we're doing? This is based on yesterday. So if you didn't do your homework yesterday, it's going to catch up to you, like right now. So what you should get when you plug this all into your calculator, and my hope is that you're at least trying this, because if you don't try this, you won't know if you know how to use your calculator. If you don't know how to use your calculator on your test or your assignment, you're going to lose silly marks. So 0.1054 is the probability of rolling it at least twice, which is 10.54%. Okay, the next piece here, it says, what is the expected number of double sixes that would be rolled? Double sixes, as soon as it says what is the expected, because this is a Bernoulli trial where we have a success or we have a failure. Success is if we roll the doubles, failure is anytime we don't. My formula is the expected value is the number of trials times the probability of it being successful. So 20 times 1 over 36, that gives me 0.5556. So the expected number of double sixes that would be rolled, not even one. If you want to round up to one, you can round up to one. But it's not very likely that in 20 times that you would roll it. That's the expected value, is you'd roll it 0.5556 times. Does anyone have any questions about that? Okay, it says here, create a probability distribution for the number of correct answers on a multiple choice quiz that has 4 answers to each question. And 3 questions, assuming random guessing. Okay, so probability distribution, we know how to do. We're going to set that up in our chart. For the number of correct answers on a multiple choice quiz that has 4 answers to each question and 3 questions. So I know here the possible outcomes that I can have here when there are 3 questions on the test, and we're assuming random guessing. So you're not even reading the question, you're just filling in letters. You can get 0 correct, you can get 1 correct, you can get 2 correct, and you can get 3 correct. Those are all the possible outcomes when you are asked 3 questions on a test. The probability of that occurring. Eric, can you help me out here? What is the probability of, again, we're talking about a success and a failure, 0 questions correct? It's not 1/2. So what would be my n value from reading this? How many questions are there? There's 3 questions. Okay. And what is the probability of success if there are 4 answers and only 1 correct answer? 1 over 4. And my Q is? Very good. So now if I'm saying the number of successes is 0, what will I write? So I use the same formula that I've used yesterday and today. No, my n is 3. So I do 3, choose 0. It's 0 and then 3. So I'm a little bit nervous right now about how many of us maybe didn't do yesterday's work. When I put that into the calculator, Pat, what do I get? Okay, give that to me as a percentage. Thank you. So there's a 42% chance that you will get no questions right on this multiple choice test. Mike, can you please set up the next probability? Mm-hmm. Okay, and Michaela, when you put that into your calculator, what do you get? Good. Ben, can you please set up the next one? Mm-hmm. 3, choose 2. Good. Mm-hmm. And not to the power of 3. That's n minus k. So k in this example is 2. You're getting, yep. Johnny, when you put that into your calculator, what do you got? Good, thank you. David, can you set up the next one for me, please? Mm-hmm. Very good. Noah, what do you get when you plug that into your calculator? Powell, can you help me out? What do you get? Powell, you doing okay? No. 0.0156. No. Another way you can get this, just so you know, is that this all has to add up to 1, as in 100%. So if you were to take 1 and subtract the first 3 values, you should get your last value. You may see a question like that on your exam. A coin is tossed 10 times. Find the probability that exactly 4 heads are tossed. Okay, Mitchell, can you please tell me what is my n value here? 10. What is my k value in this question? Mitchell? Yes. 4. What is the probability of success, my p value? When I'm flipping a coin, what's the probability of me getting ahead? Good. And the probability of failure, which is my q, is 1/2. Spencer, can you plug that into a formula for me, please? So the probability of 4 heads gives you 10 choose 4. Good. Very good. Excellent. When you put that into your calculator, Scott, what do you get? Excellent. Okay, for the probability of at least 2, Curtis, how would you set this up for at least 2? Very good. So I'm going to do for the probability of at least 2, we do 1 minus the probability of 0 minus the probability of 1. So, David, can you help me out? Can you do the first one here for me, please? Mm-hmm. Good. Excellent. Thank you. Billy, do the next piece for me. Very good. Eric, when you put that into your calculator, what do you get? Excellent. Okay, the probability that you get at least 2 heads, if it's tossed 10 times, is 98.93%, at least 2. Okay, the next question here. When making an LED TV, it is found that 0.1% of them are defective. If a store orders 25 TVs, what is the probability that they'll get at least one TV that is defective? Okay, so this is the same type of question. We're talking about, again, success, and then we're talking about failure. So I'm going to look at this as a little bit opposite. The 0.01, because we want to find out how many of them are defective, we are going to assume a defective, and I mean you could do it the other way. The defective is going to equal a success. So when I go through my information here, Pat, what is my n value going to be? Good. And my K value here is the number of successes. So I'm saying a success is a defective TV. If I want at least 1, how would I do that? Can you help me out? What would it be? I'm not, it's saying at least 1. So we're actually going to be doing the indirect method here of at least 1. So I'm going to look at what is the probability that 0 of them are defective. Okay, because at least 1 means you could have 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 25. Too much work. So we look at the indirect case. The indirect case is saying if you have at least 1 defective TV, it would be saying, well, what is the probability that you have 0 defective TVs? Okay, my p-value here, again, because success means that they are defective, 0.01%, when we write that as a decimal, is 0.001. Mike, do you know how I would determine my Q value for this? Very good, which gives me what? Thank you. Okay, Ben, can you set this up for me, please? Okay, so I'll help you out here. The probability of at least 1 is saying 1 minus the probability of 0. So I'll start with 1 minus what? Good. To the exponent. your K value. Mm-hmm. Good. Johnny, what do I get for the answer for this? Very good. Okay, so there is a 2.47% chance that you will get at least one defective TV. Does anyone have any questions about that example? Okay, the next one we will do, it says assume, it should say assume that every time Murray gets a breakaway, he has a probability of 0.6 of scoring. If he averages 2 breakaways a game, what is the expected number of goals he will score on a breakaway in a season of 75 games? Okay, so again here you have to think there's 2 options. He can score or not score, which makes this we can use our formula here because there's two options. The number of games is your n value, which is 75, and the probability of success is 0.6. Now, as soon as it says what is the expected number of goals, I can use my expected value formula. Expected value is n times p. So Ben or David, what would I plug in here? If he averages 2 breakaways a game, what is the expected number of goals he will score? That's saying 75 games. Yeah, or we could just take our answer and double it, right? So what would I expect here? I think I get 90 goals if he has a 60% chance of getting a goal in a game. No. Are we okay with that? Pardon? Okay. It is estimated that only 2% of the bolts that are machined are declared defective. Do you have your admittance slip? What took you so long? Okay. Yeah, they're up there. Okay. It is estimated that only 2% of the bolts that are machined are declared defective. In a package of 50 bolts, what is the probability that there is at least one defective bolt? Okay, so when I'm doing this, again here, if I look, n is my 50, which is the number of bolts. I want here the probability of at least one defective. So the probability of at least one defective, Johnny, what would, or Noah, what would I write for this? Like what math would I have to do of at least one defective? No, I just want it in general. If I'm finding at least one, what do I set up here? Am I going to find the probability of 1 plus 2 plus 3 plus 4 plus 5 defective all the way up to 50? So what will I do? Good, so I'm going to take 1 minus the probability of no bolts that will be defective. Okay, so I know n is 50. Again here, I'm considering that a success is a defective bolt. So again here, my K value, which Noah said is I'm actually finding the probability of 0. Powell, what will be my probability, my p-value here? Very good. And what will be my q value? Good. 0.98. Mitchell, can you set this up for me, please? Very good. And when you plug that into your calculator, you end up getting 0.6366. Anyone have any questions about that? Okay, the next question. A game consists of rolling a pair of die 10 times. Each roll where the die sum 6, 7, or 8 awards a player of $1. If the cost is $5 to play the game, is the game fair? Okay, so in order to do this, I would have to figure out, again, if you were to draw your dice chart, so I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The numbers that would go in here Okay, those are all my possibilities when I roll a die 2 times. So it's saying if I roll a die, if I roll a sum of 6, 7, or 8, I get $1. So what is the probability that I roll a 6, 7, or an 8? Spencer, can you help me out? Very good, 16 over 36. So Spencer would get that by 6, 7, or 8. Adding up all those numbers there, that gives you a total of 16 out of your whole 36. Okay, so when I'm talking here, if the game, if it costs $5 to play, how do I figure out if the game is fair? I have to calculate the expected value. Well, how much money are you expected to win? So when I do that, the expected value of a 6, 7, or an 8, when I roll a die 10 times, becomes 10 times 16 over 36, which gives me what, Spencer? Sorry? Very good. Okay, so would we consider this to be a fair game? Curtis? No. If it costs $5 to play, it's a fair game if you're expected to win $5. But you're not expected to win $5. You're expected to win $4.44. So I have here, I'm going to write down here, just so you have it, if cost is equal to the expected value, the game is fair. If the cost to play is greater than the expected value, it's not fair. So this is a case here where it costs $5 to play. This is a not fair game. Is the game fair? No. Does anyone have any questions about this example? Okay, our next example says if the probability is 0.15 that Lucy will hit a bullseye on a dartboard, what is the probability that she will get at least one bullseye in 10 attempts? So David, what do I know here? Can you tell me some information? My n value is 10 because I'm doing it in 10 attempts. Pardon? Say that again for me, Ben. It's at least one. Yeah. Well, yes. Okay, so tell me what else I know. David, what is my what is my p value going to be? Good. What is my q value? Good. Now again, because this is an at least question, it becomes the probability of at least 1 equals 1 minus the probability of 0. And when I do that, it becomes, so I'm going to look at specifically here, k is equal to 0. So Billy, what will I write here? 1 minus what? Okay, which gives you a final answer of 0.8031. So there's an 80.31% chance that she will get at least one bullseye. So that's including 1, 2, 3, 4, all the way up to a possibility of 10. Note, you're going to wait till the note's done. Okay, question number 10. It says, find the probability that at least 3 students in a class of 30 were born on a Saturday. Okay, so if I'm talking here at least 3 means I'm going to find the probability of what? Eric, what would be the easy way here to do this if you had to set up this problem? Excellent. Okay, so I now have these cases because it's much easier to do this version instead of going from the probability of 3 plus 4 plus 5 plus 6 all the way up to 30. Okay, so now when I set this up, so these values in the brackets here are my k value. N would be equal to what, Pat? 30. What is my probability of success, Pat? How many days are there in a week? And I want to know how many were born on a Saturday. What's the probability of that? 1/7. Q is 6/7. So when I set this up, the probability of at least 3 is equal to, Mike, give me the first one. 1 minus the probability of 0. What do I write? Okay. Good. Very good. And I'm going to subtract that from the probability of 1, which is, Michaela, what? Good. Excellent. Minus the probability of 2, Ben? Yep. Good. Good. Okay, and when you plug all of that into your calculator, you will get 0.8226. So there's an 82.26% chance that students were born on a Saturday. At least 3 of them were. Okay, the next one. It was estimated that the Beatles' music was played on every popular radio station 40% of the time. What is the probability that if you turned on 10 of these stations, that at least one of the stations would be playing a Beatles song? So again, here, as soon as we see the word at least one, we know we're going to do an indirect case. So the probability of at least one is equal to 1 minus the probability of 0. What would be my n value here, Johnny? N is the number of trials that I do. We know we have k value here. What is the probability of success, Johnny? (0.4). And my success for failure? 0.6. So David, when I set this up, what do I write? Very good. And when I plug that all into my calculator, you get 0.9940. So there's a 99.40% chance that at least one of the stations will be playing a Beatles song. Okay, last example. A bag contains 2 blue, 4 red, 6 yellow, and 8 green marbles. If 5 marbles are chosen at random, what is the expected number of each color you get? So this is like a 4-part question. I have to figure out for blue, red, green, and yellow. So if I look here, I have if 5 marbles are chosen at random. So n will be equal to 5. My NS is the number of marbles that I'm selecting. What are the number of marbles that I'm selecting? What's the amount? 20. So I know that there are 20 marbles in the bag. I'm choosing 5 of them. That's like saying 5 trials. So it wants to know what is the expected number. Well, expected value, again, when we're considering, again, a success in the failure, or not a success and a failure, but is n times p. So when I do this for my expected value for blue, I'm picking 5 marbles. How many blue marbles can I expect? So I do n times the probability of what? Pardon? It's 2 over 20. Good, which gives us an expected value of 0.5. Then I can find here the expected value of red becomes 5 times what? Noah, can you help me out? Good. Which gives me an expected value of 1. I would be expected to choose 1 red. My expected value of yellow would be, what would I write out for that, Powell? Times what? 5, which is the number of trials, which gives you 1.5 marbles to expect. My expected value of green is equal to what, Mitchell? Very good. 5 times 8 over 20, which gives us an expected value of 2. Okay,